This could be the start of horsepower's ultimate budget engine build. The challenge, find a high-performance used 360 Mopar small block, tear it down and build it up with a minimum of new parts, all on a budget of $1,500. Since scouring junkyards and swap meets can eat up a lot of time, we started our search online, where you can find a used engine modified with quality aftermarket parts like heads, ignition, and so forth. You've at least spent your money well.
We found this 360 with a lot of performance parts on it for $475. For example, the previous owner had upgraded to a Morosa oil pan that still looks good. Now the water coming out of the block looks normal, which is a good sign. The wires had been replaced, but they're now too brittle for reuse. And the distributor was pretty corroded on the inside. The Edelbrock valve covers are keepers, and so are the aftermarket roller rockers and original rocker shafts, even though they show signs of an engine that sat outside for a long time.
We're not sure about these rusty springs. Hopefully we can save them with the cleanup. Our 360 had been modified with an Edelbrock Performer air gap intake that will go back into action. With the intake off, we can see more evidence of condensation. Those lifter walls would normally be covered with oil instead of rust. We'll find some use for this PowerMaster alternator down the road. Good. Meanwhile, these aluminum heads will be good to go after a cleanup.
Next, I want to mic one of the cylinders to find out how many times this motor's been machined in the past. They measure out at 20 over. The lifters were also upgraded at one time and are definitely reusable. It also has an electric water pump that cost a couple $100 new, but we won't know if it's good until we put some power to it.
And what's this? Your guess is as good as mine. Seeing this much water in the oil pan might make you nervous about a possible cracked block.
Unbelievable.
But since we saw no signs of a cracked cylinder, we'll just point the gun at more condensation. And believe it or not, this gunk from the oil pan is just more evidence of that. But here's a very decent discovery, a perfectly reusable double roller timing set. And a still good roller cam we'll stuff back in during the rebuild.
Looks like we've got a pickup that matches the oil pan and a high volume pump that shows no sign of damage. The main caps will be fitted with new bearings, so now let's see what the pistons look like. They've also been replaced recently, but the rods are original, so we'll set them both aside and just replace bearings. Finally, the crankshaft, which so far looks like a keeper as well.
Well, no doubt, we lucked up. Our Junkyard 360's got plenty of high-performance parts ready for new life. That is, after a cleanup of them, the block, and replacement of customary things like gaskets, bearings, and so forth. Anyway, we're on our way to reaching our goal of building a potent Mopar small block on a total budget of $1,500. Horsepower's Junkyard 360 project is well underway. Now it's time to give this Mopar block a good hot bath. Chances are you don't have a sonic cleaner in your garage, but for about $20, you can take yours to a machine shop for a hot tank job. Now, as far as other machining goes, this time we're going to have to pass. However, we checked the cylinder walls to make sure they still have their crosshatches and don't have any scratches. The lifter bores are smooth and unblemished, and the old bearings show no signs of abuse either. So because of that and our rock bottom budget, this time we're moving on.
While the block's bathing, we can finish cleaning up these aluminum heads. Now the sonic cleaner took care of the rust on the springs, but we still have some gasket material left to remove. And we need to clean up the surface around the combustion chambers.
After two 15-minute cycles, the block's ready to come out of the sonic cleaner. While the grease and grime is gone, there's still stubborn old paint on the block. Now here's where we need a coat of duplicolor stripper, a good old pressure washer, and a partner willing to do the work. With the block totally clean and bare, a little compressed air helps to speed up the drying process. Now there's a race against rust, so no time to waste, masking off the head mating surfaces and all the openings. Then a couple coats of duplicolor engine enamel, which dries quickly.
Before we can start filling it with parts, we need to chase all the bolt hole threads to get rid of any debris. This is vital to getting the proper torque values. Then go into the cylinders with a Scotch pad to clean up the walls. Now we can wipe them down with acetone before coating them with oil to prevent any new rust. Even on the barest of budgets, new bearings are a must for the bottom end, even for the camshaft. You need a special tool for this with different size heads. First, to punch the old ones out. You have to knock out the freeze plug, of course, to get rid of the rear.
Here's some close-up proof of why a bearing replacement was imperative with this deal. There's not only scarring inside this bearing, but a joint where it was put together, and that creates a rough edge which could nick a journal, and they're all that way. Our replacements from Summit are one piece, which totally eliminates that problem.
The cam bearings are different sizes. See how it goes to the first and the second journal, but stops at the third? We know it's the right one. Now this black line I drew is perfectly opposite with the oiling hole that lines up with the hole in the block. Now once we drive it into place, we'll know it's in the exact location.
We also got a new main seal and new bearings for the mains to get covered with plenty of assembly lube. Now the crankshaft can go back home in the block. We discovered it's got a 358-inch stroke. Next, the main caps with new bolts. And that's the way an installed crank should feel like.
We're still going to mount the magnetic base and dial indicator to check the crank thrust. It should be between 2 and 7 thousandths and not to exceed 10. Now we're at 5, which is near perfect. We opted to use the pistons again and even the rings. The rods, however, get brand new bearings before we install the assemblies into the block. Now we discovered the second-hand solid roller cam came from Comp, and they told us it's got a duration of 230 on the intake, 236 on the exhaust at 50 thousandths. Now the lift comes in on the intake at 553, 565 on the exhaust, which makes it a pretty stout street cam.
As we mentioned earlier, the oil pickup and pump are good to use again, along with the old pan, which looks a little better after a cleanup.
Remember those nasty old lifters? Well, the sonic cleaner made a big difference. They've soaked in oil since then, and after installing them back in the block, we're ready to soak them and the cam with more oil.
We're lucky one of the previous owners stepped up to these Performer RPM heads. Inside those 63cc combustion chambers are valves that measure 202 intake, 160 exhaust. New Felpro head gaskets, of course, and those 171cc intake runners should help in the power department.
Of course, another plus is having this RPM air gap manifold to work with our heads, and we're even giving it new bolts. To finish the valve train, we just drop the push rods back in place, reinstall the rocker arms and shafts, and lash them down. Now we're ready for the valve covers, and we can't go wrong, they're old classic Edelbrocks.
Well, she's not the prettiest engine we've built in this shop, but today's drill is all about budget and about horsepower in the dyno, and that's where we're going to be next. Our challenge was simple. First, find a used, cheap but complete Mopar 360 engine, which we then tore down here in the shop. By the way, we were bound and determined not to spend more than $1,500, including the $475 we spent for this small block.
After cleaning the block and giving it a fresh coat of paint, we're ready to reinstall the performance parts that are still in good condition. We are using new bearings for the cam, the mains, and the stock connecting rods. Now nearly buttoned up, it's getting swapped to the dyno cart for a quick ride to the dyno cell. Only after we finish it up, fire it up, and run it, will we know if we succeeded or if we spent money on a dud.
So now you know where we stand so far with this budget Mopar project. But do you know where the name Mopar came from? Well, I gotta admit, neither did we till we looked it up. It seems that back in the 30s, a think tank for Chrysler was charged with coming up with a catchy word for their new aftermarket motor and parts division. Some genius decided to put those two words together, motor and parts, and you got it.
Here's something we noticed when we were getting the balancer ready to reinstall. This TCI piece is neutral balance for an internally balanced engine. The only problem with that is these LA360s are externally balanced, and you can see that with the counterweight built into this one. Now I can only imagine how bad this motor danced around. That's probably a good reason why it was laid to rest. Now I'm priming it and turning the motor over at the same time so the holes in the cam line up with the holes in the block to come up through the heads and oil the rocker shafts. If you don't turn it over and the holes aren't lined up, the top of the motor won't get primed. As we mentioned earlier, the old distributor had to go, so we invested in an MSD Pro billet, which will plug right up to the dyno's ignition. We also shelled out for a set of their plug wires.
This is how we're going to feed our 360. It's one of Summit Racing's street strip carbs we've used before. This is the 750 version with mechanical secondaries. Now this is the most expensive extra part we had in our budget, but it only cost about 340 bucks, so we're still in good shape. It's not a budget build unless it runs on pump gas.
Oh, let me see it, Mike. Let me see it.
Okay.
Hold still.
Don't rub it.
We had a little delay in this engine build, and that kind of explains why I'm wearing these sunglasses. I was grinding on one of the head of the bolts on that thing and got a metal shard in between my safety glasses, and it stuck in my cornea. Now, it hurt like hell and took about 2 hours in the emergency room for him to get it out. Now, needless to say, I was pretty lucky that I didn't lose an eye. Now, something else that's pretty cool is they use the same tools that we use in here. A metal burr, a pick, and even a Q-tip to get the thing out. Now, what I'm really trying to stress is make sure you're using the proper safety glasses for the kind of work you're doing. I'm gonna get a set that covers the top and bottom of the eyes so I don't lose one next time.
I'm sure it's been a while since these parts all danced together. Sounds like someone is out of step.
Then we have one valve's off. Right here? Yeah. Looks like I got in a hurry when I set this one. Let's try it again. Good oil pressure, stable water temp. Air fuels are good. Well, she comes up quick. Nice power curve, nice torque curve. What do you think the numbers are? Wow, pretty good. 419 horsepower, 438 foot-pounds of torque.
Can you imagine what this thing would sound like with that old balancer on there?
God.
Just idling.
Well, just imagine looking into it. It would be dancing all around on that cart. Exhaust would be shaking. We'd have thrown a bearing out of this thing by now.
Yeah, it could have been interesting.
Oh man, yeah, it would have been nasty. Let's add another 2 degrees. And the secondaries come in.
Wow.
440, 466. That's a really cool torque curve. I mean, I don't think I've seen one that just perfectly flat. Super smooth too. You want to see where we max out on our timing?
Yeah, because
we
might take another degree, don't you think?
Yeah, it's still going. We bumped it up to about 35 and a half.
Okay.
Same RPM range. See what she got. .442, 467. I'd say with that little of a gain, we're about maxed out. If we put any more in it, we're going to start going backwards.
So what we got here, that's very respectable. Not only did we hit good power numbers, we also hit our numbers budget-wise. 475 bucks for the used engine, about 930 for new parts, so at a little over 1,400, we're well under that $1,500 limit. Of course, it's a gamble anytime you get a used engine. You never know if the block's got a crack in it or what shape the valve train's in, but hey, this time we gambled and won, and anybody with one eye could see that.
Nice.
You're watching Horsepower. For a DVD copy of this episode, just go to PowerBlockTV.com and order your copy for just $5.95 plus shipping and handling. Start your own horsepower collection, delivered right to your door from the Power Block.
You've heard it before. The only horsepower that counts is the horsepower you can plant in the ground. The 2010 Camaro comes from the factory with impressive power, but they've got an inherent tendency to wheel hop. Wait a minute, let's see that a little closer. Wheel hop is caused by loading and unloading the factory rubber bushings and stamped steel used in both the rear toe links and trailing arms. It not only makes for a lousy launch, it kind of makes you look stupid at the strip. We've got some new suspension upgrades that'll heal the hopping problem and improve the overall handling characteristics of the car. First, though, we need to remove the OE trailing arms that are attached to the rear cradle. While we're at it, we'll also remove the factory toe links that are attached the same way. All right, now time for the old side-by-side comparison. These Lakewood lower control arms are made of heavy gauge tubular steel to eliminate the flex you get from these stamped steel pieces. Also, they have polyurethane bushings for stability. Now, the Lakewood toe links are a vast improvement over stock, a lot stronger, fully adjustable, and they too have the polyurethane bushings. Both pieces are powder coated for good looks.
Make sure to support the suspension at ride height to install the new trailing arms and toe links, and you'll reuse the factory hardware. We've also got something to stiffen up the unibody chassis. Lakewood just came out with tubular subframe connectors for the Camaro that use threaded tabs to join the rear subframe to the front, and each one uses a brace that attaches from the connector to the differential cradle. To finish firming up the Camaro, we're installing one of Lakewood's powder-coated steel strut tower braces. This will help reduce flex during hard cornering.
If this Camaro looks familiar, you probably saw it on the POWERBLOCK recently as one of the cars some lucky winner can choose from in the MMX sweepstakes. The other choices are a new Mustang GT and Dodge Challenger SRT. If the winner chooses this Camaro, well, they'll be getting one with better handling, less flex, and now with no wheel hop. And to the winner, sorry about those tires.